All right. Today, all right. So, calculating probabilities.
Lily Oates, grade 6 student, could you come to the office now, please? Lily Oates, grade 6 student, to the office now, please.
All right. We use the calculator to calculate probabilities, and so that you can do this. It can be done from two places. So it can be done from the main screen, and also it can be done from the statistics application. So I'll do an example of both of those. All right, so let's have a look at an example. So, for example, e.g., we're asked to find the probability that -1 is less than z is less than 2.5. Now, whenever you see z, that means we're looking at the standard normal. And so what that means then is that we have a mean of 0 and a standard deviation of 1. All right, so let's have a look at how to use the main screen. So from the main screen you go main. After that you go to the interactive menu. Then you go to, on the interactive menu, so the main screen, interactive menu, then you've got distribution inverse dist. And so you click on that and you'll see a bunch comes up. So the normal distribution is a continuous distribution. And so you click on that, continuous, and then you've got that option, and we want the norm CDF is what we're after. Cumulative C stands for the normal cumulative distribution function. And so we use that when we want to find between some things. So we click on that, and then you get this box that comes up. So then you're asked to fill in. So the default on your calculator is the mean of 0, standard deviation of 1. So that's our default. We can change those if we need to. In this case, we've got Z, so they can stay. So when we're talking about the lower, we're talking about this number here. And this one is our upper. So you just put those in the appropriate box. So -1. In the lower box, 2.5. In the upper box, then you go OK. And it does a calculation for you. Here it is. That's how it now sets it all out. And so here we've got a whole bunch of decimal places. Now in the exam they will always tell you how many decimal places to do it to. It's very often 4. So that probability between -1 and Z and 2.5 for Z to 4 decimal places is 0.8351. Alright, so I'll do another one. Let's do another example. I'll do another example where I show you the statistics application, just so that you can see the difference between them. Right, so let's find, e.g., find probability that Z is greater than 1. Again, we're using Z, so our standard deviation is 1 and our mean is 0. Alright. And in terms of our limits, this time we want Z to be bigger than 1, so our lower is 1 and our upper is infinity. Now, we don't have an infinity, so you're just going to make sure you use a big number. And I'll show you that in a minute. Alright, so how do we do this? So from the statistics, so if you're doing it in the statistics, you go to the statistics app. And then you go to the Calc, so the Calc menu, because we want to calculate something. So on the Calc menu, there's a whole bunch of stuff here. And what do we want to calculate? We want to calculate some distribution. So we go to distribution. And then when you click on that, we get a screen up that says, what do we want to type? Distribution. What do we want? And then there's a menu down there that you can get. Yep, so there's a whole bunch of different stuff that you can do there. Alright, and we after the second one on the list, the normal CD. So the distribution, the one we want is normal CD. Cumulative distribution. Alright. Then we go next, and then we fill in the stuff. Fill in the stuff, enter values, and then we go next again.
What's the big number we should put in for that?
Alright, so our lower was 1, was it 1? Yep, 1. Our lower is 1, upper, if you just go EXP99. That's a big number, 10 to the power of 99. And if you do that, so whenever it goes infinity, that's the easiest, just go EXP 99. Then next, So the probability that Z is greater than 1 is equal to 0.1587. Now, the thing that you can do here on this statistics, through the statistics app that you can't do through the main screen, is you can draw a graph. Yes, Nick?
How'd you get that E thing?
The E thing,
10 to the power of...
EXP,
Oh, there it is, right.
99.
And then you put it to the power of...
Yeah. Alright, so the thing that you can do here on this screen in statistics that you can't do in the other one is you'll notice that you've got that little graph icon up the top. So what we can do is you can click on that. And there's the normal distribution. And the shaded bit here's the bit we're after. Right, so some people like that, because they like to get that visual as to what's going on. But both ways give you the answer. Some people like to see that it makes a bit more sense to them. And you can see if we're looking at greater than 1, and you can see the shaded bits up here greater than 1, so you know you've got the right thing. All right. You can also find values. So if I want to know the value of X or Z, where the probability of getting less than that or more than that, or between a couple of is a certain percentage, you can use that for this as well. Alright, so here's an example. So X is normally distributed. With a mean of 100 and standard deviation is 6. I want to find K. The probability that X is less than K or equal to K is equal to 0.95. Alright, so seeing as we are already on this screen, if you notice there's a back button here, so we can click this back button and go back and make changes. So if I go back all the way to the front, the normal CD, we've got distribution up here. Now you'll notice here, so this time, because we're starting with our probability and we're going back, so that's where the inverse. So right, we started with this, found the probability, we're going back the other way. So we need to, for this, we need to use inverse distribution. Alright, so this one here, inverse distribution. Alright, and this one's already got inverse normal, so we're choosing inverse normal, CD. Next, tail setting. See here, it's got a tail. Right, so what it talks about when we're referring to the tail, to these bits here, there's a tail, there's a tail. And this one here, it's got centre, it means if we're looking for something in here. And so what do we want? So when we're looking at this, we're wanting x less than or equal. So the probability x is less than or equal on our graph. So here's our k, for example. We're looking for this bit on the left. So in this case, our tail is to the left. If we were looking for, say, the probability of greater than or equal to some number, there's our number, that'll be this bit here, and our k is, our tail I should say, is to the right. If we were looking for the probability to be between two numbers, so like that, then we use centre. Alright, so in this one we're looking at less than or equal to k, so we're looking to the left. So we want our tail to be the left. So our tail is left. For this one, to the left. Our probability that we're after, that's the number on the end here, 0.95. And in this case, we're not looking at the standard, but we're looking at one where we're given a mean and a standard deviation. Our standard deviation is 6 and our mean is 100. So probability, put that in, 0.95. Our standard deviation is 6, our mean is 100. Alright, no more stuff there. It says to scroll, not to worry. Next, and there it is. So it's telling us this here, up the top is our k value. So what we found from that is that k is equal to 109.8691.
I didn't get that. I got 88.34
Really?
What was that tail saying?
Left.
Oh, left. Alright, I didn't realise.
So if I graph that,
There we go. Got the right answer.
there it is. There's the graph. Because we're after less than. So we want less than k. So down here. So we're looking at this tail down here, the one that's to the left. All right.
Don't rub that off yet.
All right. I won't rub it off yet then.
Too much time changing between the dollars and $20.
Is it how much is this calculator? Thanks.
Can I?
Yes.
Yep.
All right, a couple more examples and then we're done. So, first example. I'm going to use the other hand here. The English teachers wouldn't be happy, but I won't worry about that.
Is the symmetrism normal distribution just moving to bell curves?
Yep. It's exactly what it needs, it's the bell curve. Alright, so this thing's making these metal rods, and the metal rods, they're acceptable if their length is between 1.925 centimetres and 2.075 centimetres. And we're told that 5% are rejected for being undersized, 5% for being oversized, and we've got a normal distribution. Find the mean and the standard deviation. So, undersized, that would be less than this. So the probability that x is less than 1.925, 5%, 0.05. They get rejected if they're too long as well. So probability of being too long, which is more than 2.075, is equal to 0.05. All right. So we're then asked a couple of things. We're asked to find the mean and standard deviation. Now, there's a few things that we know about the distribution to normal. A few things we know about the normal distribution. What do we know about the normal distribution? Symmetrical, all right, so symmetrical, all right, so this first thing. So what do you notice about the probability of those that are undersized and oversized? They are the same. So, because they're the same, and that's this one here, 1.925, and this one here, 2.075, then the mean, which is in the middle, is going to be halfway between these two. All right, so if that's 5% there, 5% there, we've got 90% in the middle. All right, so to find this mean, the easiest way to find this mean would be to add them together and divide. Yep. All right, and we can do that because we know it's a normal distribution and we know the normal distribution is symmetrical.
Are all of them symmetrical?
All normal distributions are symmetrical. If it's not, then it's not a normal distribution. Something else. All right, when you add that up and divide by 2, you'll find you get 2. All right. Now, the next bit's the tricky bit, finding the standard deviation. So, what I'm going to do is I am going to just look at this bit at the end. So I'm just going to look at this part. That's that part there. And that part there, the probability that x is less than 1.925, I know that is 0.05. That's 5% less than that. What else do I know? Well, I know this z. So we recall that z is equal to x minus the mean over the standard deviation. Now I've got this x, I know what this x is. We found the standard, the mean. So if we could find a z that corresponds to this x, we could put those things together. So this is what we do. So what we're looking at then is, what about the probability that z is less than some number, call it z, being 0.05. Alright, so,
What little z is that?
oh, it's just a z, little z, z,
But it's the same.
it's a number. Right, so this is the standard normal, and this is the distribution we've got. So there's a connection between, with the same probabilities, 0.05, there's a connection between the two. And this here is the connection between the two. Yes, Nick?
How can z be less than
How
z?
can, eh?
How can
It's a
z-
number.
Oh, Z1. All right, call it Z1.
Is it
Big Z, little z.
Just some random number.
It's just some number, yeah. And the Z, we're using the Z to say that that's the standard normal, that one. Because this distribution, we would just transform that in some way. You know, move it, stretch it. All right? So there's a connection between the two. And the connection between the two is this here. So if I use the inverse normal, so inverse normal on that, so let's go back to our inverse normal. Let's go back. All right, so tail setting against less than, so to the left. Probability 0.05. And our standard normal, mean of 0, standard deviation of 1, tells us that our x value, or our z value I should say, not x, so when z is equal to negative 1.64485, then the probability, there it is down here, that probability in there is 5%. So our x value is this. So for our this distribution, mean of the 100 standard deviation, no, mean of 2, sorry, standard deviation of yet to be determined. When x is 1.925, we get a 5%. So we've got some information now, so now I can take this z that I've got here and I can take that and I can stick it up in there. And when I do that, what have I got? When I do that, I've got, so, I've got negative 1.64485 equals x, and x is 1.925, minus the mean, which we found out to be 2, over the standard deviation. Rearrange, times both sides by the standard deviation, divide both sides by,
Is the standard deviation 1?
of this, of Z it is, but not of X. And we're trying to find X's standard deviation. So this conversion factor, the mean and standard deviation in this conversion factor are those for X. Alright, and when you do that, you find that the standard deviation of this is 0.0456. Alright. That is the end of that example. So we found the mean to be 2 and the standard deviation to be that. All right. The last thing we can do with the normal distribution is we can use it to approximate the binomial. So it's called the normal approximation to the binomial. Distribution. And what we can do this is we can, do this.
I don't know what's going on in this whole topic.
A large number of trials. Right, so the more and more trials that you do, the more and more the binomial distribution looks like a bell, and so then we can approximate. So when we do that, what do we use? So our mean, well, for our normal distribution, for our binomial distribution, it's just our number of trials times the probability of success. Standard deviation, or standard deviation, is the square root of the variance, and the variance is n times p times q, which is 1 minus p. So if we have a large number of trials, we can use the normal distribution using these values as our mean and standard deviation, and we can get our calculator to do it for us. So we will do an example, and I'm going to use one out of the textbook. So example 9. Page 678. Alright, so sample of 1,000 people. So first up, already we've got some information. There's 1,000. That's a lot of people. From a certain city, we're asked to indicate whether they're in favour of a new freeway. It's known that 30% of the people in this city are in favour. So the probability, because remember here, are you in favour of freeway or are you not? So the thing that we're looking for is whether you're in favour of the freeway, and it says here that we've got 30%. So that would be 0.3. So if you're not in favour, it would be the rest. Alright, find the approximate probability that between 270 and 330 in this sample were in favour. So we want to know what is the probability that the number in favour is between 270 and 330.
There only one part to that question.
Only one part to the question, yes. All right, what do we need to know? We need to know the mean and the standard deviation. So the mean,
What is P?
probability of success. And in this case, we're interested in people who are in favour of a
So when
freeway.
it says 30% are in favour of the freeway, is that all of the people that are in favour of the freeway, or is that just a proportion?
That's a global, we get to sampling in next, when in this case,
No, but like as in, when they say it is known that 30% are in favour, does that mean
that
only 30% are in favour, or does that just mean that there are 30% in favour?
there are 30% in favour for the whole population, they're saying.
Oh, okay,
And so for the whole population, 30% would, but we're just sampling 1,000.
Do you mean to put some sort of sign between x and 330?
That one?
Yep.
All right, we need a mean, we need a standard deviation. So the mean is just 1,000 times 0.3, which is 300. Standard deviation is the square root of 1,000 times 0.3 times 0.7, which when you work that out, you get square root of 210. All right, so to find this, we go to our calculator. We go to the normal CD. We go next. We go, our lower limit is 270. 270. Our upper is 330. Our standard deviation is square root. Let's go keyboard. Square root 270. How nice is that? And our mean is 300. Let's get rid of the keyboard. And then we go next. And the probability of that is 0.9321. Lower, upper.
What was it inverse normal CD or?
No, just normal. Because we're going from here to a probability, we use the inverse when we've got a probability and we're going to the number. So here we're going from the number to the probability. Now you notice on the calculator, see how it's now, here it's got Z low, Z up, so it's actually changed these numbers to what it would represent in the standard normal. Again, if you want to have a look at what that looks like, there it is there.
Why did you put in square root of 270 when it's square root of 210?
Is it 210? Because I put the wrong number in. I'll go change that. 210. There. What are we doing? Stupid thing. That doesn't like. I'm going to have to go back. There we go. Let's try it now. That's better. Next. There you go. Is that better?
Yep. Thanks.
So 0.9616.
Smile, maybe subscribers.
All right. That's it. Done. The rest of 16, C, D and E.
97. I think you're so big you're going to have to start donating to charity.
Donating to charity? Why?
Because,
I already do. I donate to CareFlight.
what is that?
CareFlight is an organisation that they run helicopters, so that if people need to be helicoptered to and from hospital and things like that,
It's like royal flying doctors, but not.
yeah. So normally if it was the ambulance helicopter, you would have to pay for the ambulance helicopter unless you were an ambulance member.
Yeah.
Well, this CareFlight helicopters people and they don't have, people don't have to pay. It's they're a charitable organisation. So I donate to them.
And they're like, why am I for
You better tell them
Oh.
what you're subscribing
Because when I broke my back, Care Flight flew me to the hospital.
Why is Care
How did
Flight
you
that
break your
really
back?
sad ad?
No, that's
No,
angel
angel
flight.
flight.
Oh, that's a shit. That makes me cry.
That is
That's a horrible.